All right, welcome everyone. Okay, this particular video is about exponential functions, so let's begin. I'm just going to move this over here. All right, and so what you're looking at when you look at exponential functions is you basically are looking at a different type of function. So you see they kind of have them labeled. It's some number raised to the x power is what you're looking at. So we'll go into a little bit of that in detail. So you're going to be able to determine domain and range for any given graph, find f of x if we give you x, and recognize an exponential function. Okay, so review of domain and range, just if you remember, domain is your input values for a function or x, and then range is your output values or your y. Okay, so this would be domain, this would be range. All right, so when you look at this function, domain and range, your domain would be all real numbers. What a couple people did is they just looked at the points and named those because the line doesn't have an arrow, so I totally get that. And then if you look at your range, you're going all the way up and down, so again, all real numbers. Okay, if you look at this one, your domain is all real numbers. It only goes from this point up, so its y is greater than or equal to -9. Now, if you look at this one, your domain here is all real numbers, but if you look at your range, it's also all real numbers because it goes up here and then it goes down here. Okay. If you look at this one, your domain here would be all real numbers, but your range would only be from -1 to +1 because that's as far up and down as the graph goes. So even though domain is everything, y is only going from here to here. Now, if you look at this function, your domain here would be all real numbers, but your range would only be numbers y is greater than or equal to 0, because notice it's above the x-axis. We'll talk about that a little more later, but that's how you would define that one. All right. All right, so now here we're looking at evaluating functions. Most of you have done this one before, so it's not a huge deal on how to do it. Let's see. I seem to have lost my eraser, but basically what you do on this one is if f of x equals x plus 4, find f of -3. Replace x with -3. So you're going to get -3 plus 4, so it's 1. Here you're going to replace x with 2. So -4 times 2 is -8, minus 2 is a -10. Okay? And then the same thing here. Each time you're just replacing the x with whatever number is in the, when you replace this x, you might want to put in parentheses the correct answer. Okay. And then the next part, this is just information on an exponential function. This is really the meat of what you need to know. So an exponential function is a function of the form y equals b to the x power. Well, b is a positive constant called the base and not equal to 1. Your exponential functions are either increasing or decreasing. Let me move that over just a little bit. Exponential functions also have a horizontal asymptote. That's going to be important later when we talk about logarithmic, which is the inverse. And the definition of an asymptote is it's an imaginary line that a graph approaches but never touches or crosses. Okay? Feel free to pause as you jot all of this down. Okay? Now, here, what I would do, because this is the formula, is either f of x or y, and b is greater than 0 or b is not, and b is not equal to 1. And then I would just plug these in on the calculator. So here it would be 2 caret key x. Okay, that's how you would do that. Here, 3 caret key open parentheses x plus 1 close parentheses, because you want to make sure it does that. Here, I would either do 0.5 or you could do 1/2 in parentheses. But when you do the caret key, make sure the x minus 1 is in parentheses. Okay, so and it's just some examples so you can kind of see how that works. Okay, all right, give me just a moment and we'll continue on. All right, picking up on here, these are 8D. Okay, so we're still working on exponential functions, and then notice there's not many slides. These are the things you're going to need to be able to do. Identify x and y intercepts, zeros, in behavior, increasing, decreasing, horizontal asymptotes, continuity, and domain and range. Okay, so let's move on with that. Okay, So here we're just gonna, this is probably, I think, probably the most important slide that you do, okay? So we're just gonna jump down here and do this. So your domain is basically all real numbers. This is x such that negative infinity is less than or equal to x, which is less than or equal to positive infinity. All real numbers is fine. Your range is always all positive real numbers, so y is greater than 0. The points that are on every exponential parent function, I'm going to move this out of the way a little bit. I just want to get it out of the way so we can see that. Okay. 0, 1, 1b, so whatever this number is, if it's 2, it would be 1, 2. And then negative 1, and then 1 over, again, for our example, 2. Okay? So those are 3 points that are in every parent function. Now that changes if it's not the parent function and you've shifted the function. Okay? Y-intercept is always 0, 1. There is no x-intercept. If b is greater than 1, f of x equals b of x goes up to the right. It's increasing and it demonstrates exponential growth. So in other words, it looks like this if you just follow my cursor. Whoops. And that's not what I want to do. Okay? We'll show you in a minute. If b is a number between 0 and 1, notice it doesn't include 0 or 1. It goes down to the right. It is a decreasing function, and it demonstrates exponential decay. Okay, f of x equals b to the x is a one-to-one function, and it has a inverse function. The inverse function is a logarithmic function. Horizontal asymptote, that's what that stands for. The graph of every exponential parent function approaches but does not touch the x-axis, so the horizontal asymptote is y equals 0. It's the x. You can also say x-axis. I'm perfectly okay with that. All right. So for horizontal asymptote, let's go. Let's move this up here so you can see. Okay. A basic exponential will have a horizontal asymptote at the x-axis or when y equals 0. This means the graph will approach the x-axis but will not cross it. Now keep in mind on the calculators that is very hard to demonstrate. Okay, very, very hard because there's an infinite number of points there. A vertical shift alone or with a horizontal shift will change the asymptote, and a horizontal shift alone does not affect the asymptote. So it has to be a vertical shift either alone or with a horizontal one. If it's a horizontal shift, doesn't matter. Okay. Now, here we're going to go ahead and do one. Now, they have you filling out a table, but I'll be honest, I am perfectly good with you just using the graphing calculator. So what I did is I put up a TI, and let's go in and do one. Okay, come on. Okay, you know what? Oh, there it is. It's a little slow. Okay, I'm going to go up here, and I'm just going to turn off my wow, it's moving really slow. I'm trying to turn off this plot thing, but it's not wanting to move fast with me. So I'm going to pull up my Casio, and I'll walk you through verbally the directions for TI, because it is just not wanting to work right now. Okay, so with our Casio, we're just going to go here to 3. And yeah, I have a whole lot of stuff here because I've been working on radicals with my other class. So let's unselect that. And unselect that. Okay. And what we want to do is we want to do 2 to the x was the equation. So you're going to do 2, and then you're going to do caret key x. It works the same on the TI. Okay. And then we're going to execute. And now let's tell it to draw. Okay. I'm going to shift my window and just make sure it's standard, because again, I've been doing some other stuff with it. Execute. Now let's tell it to draw. Okay, so there you see. Okay, so what you're seeing here, this is your horizontal asymptote, and it's going through certain points, okay? That's what the graph looks like. So this is an increasing function because it does that, okay? Just wanted to kind of give you that. So what you should notice on that, remember the domain is all real numbers. Your range is going to be y is greater than 0 because it's above the x-axis. There, you can see that, okay? Your x-intercept is none because if you look at this graph, it doesn't, remember it approaches the x-axis, so it's not crossing or touching the x-axis. So there are no x-intercepts. Your y-intercept is 0, 1. Your asymptote is y equals 0 or the x-axis. This was an increasing function because it opened that way. There are no zeros because, again, there's no x-intercept. No zeros, no x-intercept, no zeros. And then your end behavior, as x increases, y increases, but as x decreases, y goes to 0. So let's look at that again. So as x increases, as you move this way across the line, y is increasing. As you move this way across the line, y is going to 0. That's what that means, okay? And then the next couple of slides is you just doing some more of those examples. So that one pretty much works the same. Now I would like to show you one that where b is between 0 and 1. So let's look at that. Okay. And so we're going to exit and go back. Again, if you are on a TI, the directions still are pretty much the same. Okay. So now it was 1/2 raised to the x. Yes. Okay. I just wanted to make sure. So, whoops. Let's go back. Hit the wrong thing. Okay. And then go to my calculator. So we're going to do 1/2. So if you're on a Casio, I would do open parentheses and on a TI as well. 1. Here, TI would hit divide, but I'm going to hit my fraction key. Okay. And then close. And then I'm going to do caret. And I'm going to do x again. Okay. Now, I didn't leave on the parent function, which would have been interesting because then you could have seen the difference. Keep in mind the parent function does this. This one is going down this way. So notice this is now a decreasing function. Okay, again, still no x-intercept. The horizontal asymptote is still x equals 0. I'm sorry, y equals 0 or the x-axis. And what else was there I wanted to point out to you? I'm not sure. So let's go back here. Oh, okay, in behavior is what I want to point out. So again, same domain, all real numbers, same range, y is greater than 0. There's no x-intercepts, 0, 1. Y equals 0, the x-axis. It's a decreasing function, no zeros. And the end behavior, let's look at that. Yeah, so as x gets bigger, y approaches 0. As x gets smaller or decreases, y increases. That's what we're looking for there. Okay? And you'll see that's what they say here. So as x increases or goes to infinity, y is approaching 0, and as x decreases, y is increasing. Okay? And then they give you another one of those there. Okay? Same thing, just so you can see. So now, this is to make sure you have it. So is it increasing or decreasing if b is equal to 5? That would be increasing in its exponential growth. B is between 0 and 1, so that's a decreasing function, which is exponential decay. The asymptote is horizontal, and it's always y equals 0 unless it's off the parent function. And then 3 points that are on it, 0, 1, 1b, and -1, 1 over b. Okay, so that pretty much takes care of that one. We're going to pause again. Okay, continuing on, I know this is making this video a little bit longer, but please feel free to stop. Okay, so here we're going to be able to describe the transformation that's made when it's written in HK or vertex form, or looking at the graph. I always find it easier to graph it and graph it with the parent function, and then it's easier to see. Okay, so here's what you want to notice, and this is what they did. A vertical translation is where you've added or subtracted a number from the function. Notice the constant is outside the function. So if you did it, the 2 to the x is, say, our parent function. So if you add 3, you shift the graph up 3. Here, if you subtract 4, you shift down 4. That's a vertical translation. Here, notice the constant's inside the function. In other words, we changed the x. So now you're shifting it left or right. So if you add 4, notice you're shifting it left. So it's like x minus a -4. And then here, if you subtract 3, basically it's 3. You're shifting it right 3. Okay, so if you're confused, please note that these are down here at the bottom. Okay, that's a horizontal translation. Reflection, all you're doing is flipping it across the x-axis. So if you put the negative out in front, which is this red one, because the green is the parent function. If you put the negative out front, it just flips over the x-axis, okay? If you put the negative on the exponent, it flips over the y-axis. You should remember reflections from geometry, and it tells you right here. That's all you got to pay attention to, okay? Here, I'm going to move this so you can actually see this. So if you multiply b times a number, you still do b to the x and then multiply it times c. So instead of adding or subtracting, we're multiplying. If c is greater than 1, you're stretching it is what they call it, stretching it vertically. And if it's between 0 and 1, you're shrinking it, okay? Blue is your parent function here. In both cases, blue is your parent function. This has been stretched. This has been shrunk, okay? And then here, if you leave B but you change X, with the purple being your parent function, you're horizontally shrinking it, and here you're stretching it horizontally, okay? So that's kind of how that works. And then this is just a sum up if you want to do that, okay? And then we have one more. All right, this last part of it for the notes for Unit 8 is all about real world problems. So we're just going to go through some of this. I'm going to skip because we did it in class, but as it turns out, we really didn't need to know it. It's just examples of you using the function is all it is. This one is the one that's important. We're jumping over to compound interest, and this is the one I'm testing you on. So A is accumulated value, so that's your answer. P is your principal, the money that you start off with. R is your interest rate. If it's in percent, put it in decimal. And T is the time invested, which is always in years. Okay. So if you invest $1,000 at 3%, how much do you have after 5 years? Where you're going to have 1 plus 0.03 raised to 5, and then you get that answer. You're going to multiply it times 1,000. And then here all you're doing is replacing the T with 20, but P stays the same and R stays the same. Okay. And so let's do, I'll show you that really quick. It's not really a difficult idea. So it's equal to 1,000 times 1 plus 0.03 raised to the 5 power and then raised to 20. Okay, so let's look at our calculator here. Let's see if I can get my TI up and working. There we go. Okay, so on this, I'm going to do 1,000. I'm going to do open parentheses. And I'm going to do 1. Come on. 1 plus 0.03. You have to change all of your rates to percents. So even if it's a decimal, you still need to change it, okay? And then I'm going to hit the caret key, and I'm going to raise it to a 5. Now keep in mind, yours is going to show a caret key. This is the color grapher, so it's does a little different. And then you're going to hit enter. And bam, you're done. And round it to the nearest penny, so you're going to have $1,159.27. That's how that works. I mean, it's not real difficult. It's just plug and chug on a calculator. And then here, what this is you just want to change it with the period. So notice you're going to take R and divide it by N, and then also do that N times T. If they tell you it's annually, this N is the number of compounding periods. So if they tell you it's annually, it's 1, semi-annually is 2, quarterly is 4, monthly is 12. They also do continuously, I'm going to say that's daily, and that's 365. Okay, so here let's do one where we're going to do the same one, except we're going to be changing, we're going to be adding the n into it. So 1,000 times 1 plus 0.03, and quarterly is 4. And then we're going to do 4 times 5, which is 20. Okay, so let's go back to the calculator. And we're going to do 1,000, open parentheses, 1 plus, I'm going to do 0.03 divided by 4. Then I'm going to close my parentheses. I didn't put a second set of parentheses in here because the calculator does order of operations, so it's going to divide before it adds anyway. Okay, and then I'm going to do caret key, and then yours, I would just say 20. But if you want to do it, you could do caret key and then do 4 times 5. Or again, you can just put in 20 and then execute. And then what you get there is you get $1,161.18. That's how that works. So let's go back. And then monthly, you just change the n to 12. Okay. Again, please keep in mind that the interest rate has to be in decimals and time has to be in years. Okay. So if you compound continuously, what happens to n? Again, I did 365 because I assumed that was daily. Okay. I'm going to skip this one because we talked about it in class, but we really didn't have any use for it. And then what they did here is they just gave you an examples of how they use it. When they're predicting if a species is going to be extinct, they use exponential growth and decay a lot. And so as you see, we're done. Okay. So thank you and see you on the next unit.